In 1972, the Apollo 17 crew left the lunar surface, marking the last time a human being stepped outside low Earth orbit. Since then, we have been confined to a bubble 250 miles above Earth. But right now, in 2026, that is ending. Artemis II is not just a trip to the moon. It is a 10-day, high-velocity stress test of the most complex machine ever built by humans. This mission will take 4 astronauts 4,600 miles behind the far side of the moon, farther than any human has ever traveled into the deep. This isn't a landing, that's for Artemis III. This is a shakedown cruise designed to ensure that the life support, radiation shielding, and re-entry systems can actually keep humans alive in deep space. If a single primary system fails here, there is no ISS to dock with for safety. It's the moon or nothing. The SLS, 8.8 million pounds of violence. To get the 57,000-pound Orion spacecraft to the moon, you need the Space Launch System, or SLS. Standing at 322 feet, the SLS Block 1 is the most powerful rocket currently in operation. At liftoff, its 2 solid rocket boosters and 4 RS-25 engines generate 8.8 million pounds of thrust. To put that in perspective, that is 15% more power than the Saturn V and significantly more than the Space Shuttle. In just 8 minutes, the SLS consumes 2 million pounds of liquid hydrogen and liquid oxygen. The 4 RS-25 engines are actually refurbished engines from the Space Shuttle program, updated with new controllers to handle the higher pressures of the SLS. The boosters provide 75% of the initial thrust, but burn out in just 2 minutes. Once the core stage is spent, the interim cryogenic propulsion stage, ICPS, takes over. This is the kicker that will eventually provide the translunar injection, the massive engine burn required to break Earth's gravity and head for the moon at 25,000 miles per hour. The crew will live inside the Orion Command Module. While it looks like an Apollo capsule on steroids, the technology inside is half a century ahead. Orion has about 330 cubic feet of livable space. For 4 people, that's roughly equivalent to living inside a small minivan for 10 days. The most critical piece of hardware is the European Service Module, ESM. This is the lifeboat attached to the back of Orion. It provides the air, water, and electricity for the mission. It houses 33 engines and 4 23-foot solar arrays that provide enough power to run 2 average homes. But here's the challenge. Deep space is filled with high-energy solar radiation and galactic cosmic rays. Unlike the ISS, which is protected by Earth's magnetic field, Orion will be fully exposed. To combat this, the spacecraft features specialized shielding. And in the event of a solar flare, the crew is trained to create a radiation shelter in the center of the cabin using water bags and cargo lockers to block incoming protons. The flight profile of Artemis II is a masterpiece of conservative engineering called a hybrid free-return trajectory. Step 1. High Earth Orbit, HEO. After launch, the crew won't head straight for the moon. They will stay in a massive elliptical orbit around Earth for 24 hours. During this time, they will manually pilot Orion to practice proximity operations. This is a checkout period. If the life support or power systems show even a tiny glitch, they can abort and land back on Earth within hours. Step 2. Trans-lunar injection, TLI. If everything is go, the ICPS fires, pushing them toward the moon. Step 3. The lunar flyby. Once they reach the moon, they won't enter orbit. Instead, they will use the moon's gravity to slingshot them around the far side. The free return part is vital. The physics of this trajectory means that even if Orion's main engine fails entirely after the TLI burn, the moon's gravity will naturally pull the spacecraft back toward Earth. It's a passive safety feature that ensures the crew doesn't get stranded in deep space. The most dangerous part of the mission is the final 20 minutes. When Orion returns from the moon, it won't be traveling at the 17,500 miles per hour of a typical ISS return. It will hit the atmosphere at 20 75,000 miles per hour. At these speeds, the air in front of the capsule doesn't just move. It compresses so violently that it turns into plasma. The heat shield, made of a material called avcoat, will reach 5,000 degrees Fahrenheit, about half the temperature of the surface of the Sun. Artemis II will use a skip re-entry maneuver. Imagine skipping a stone across a pond. Orion will hit the atmosphere, bounce back up into space briefly to bleed off heat and velocity, and then dive back in for the final descent. This reduces the G-loads on the astronauts and allows for a more precise landing in the Pacific Ocean. One fascinating technical upgrade for Artemis II is the optical communication system. For the first time, NASA will use lasers instead of radio waves to send data. This allows for a bandwidth increase of up to 100 times, meaning we might see first ever 4K live stream from the far side of the moon. Why are we doing this now? Because of water ice. The goal of the Artemis program is the lunar South Pole. Satellites have confirmed that permanently shadowed craters there contain billions of tons of water ice. Fact: water is the most valuable resource in space. It can be broken down into oxygen for breathing and hydrogen for rocket fuel. The goal: if we can harvest fuel on the moon, we don't have to launch it from Earth's deep gravity well. This turns the moon into a gas station for missions to Mars. Artemis II is the final gatekeeper. It proves that the SLS can launch, that Orion can protect humans from radiation, and that the heat shield can handle a lunar return velocity. If this mission succeeds, Artemis III will land humans on the moon within 2 years. We are moving from the era of exploration to the era of occupation. The Artemis II crew consists of Commander Reed Wiseman, pilot Victor Glover, and mission specialists Christina Koch and Jeremy Hansen. They aren't just pilots, they are test subjects for the future of our species. When they splash down in the Pacific, they will have officially reopened the door to the solar system. The era of being a single planet species is officially coming to an end. This is the most important flight of the 21st century.